going through the 2004 3 square plus 5 square plus blah 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 plus 2 to the n minus 1 square is n over 3 times 4n square minus 1. So all of that, you can call it maybe a statement Pn, and Pn is a statement such that we're summing from r equal 1 to n of 2r minus 1 all squared. You don't have to use the letter r as a dummy variable. You can use t, you can use s, anything, but you will commonly use r. We stick with r, and that's equal to n over 3 times 4n squared minus 1. So now let's get it. So now we're going to start with when n is equal to 1. All right, when n is equal to 1, when n is equal to 1, what we're going to get is the left-hand side becomes, your left-hand side is just the sum from r equal 1 to 1 of 2r minus 1 square, and all of this just works out to be 1 square, which is 1. All of this works out to be 1 square, and 1 square is equal to 1. All right, this is step 1. All right, then your right hand side is going to be equal to, when you put n as 1 in the right hand side, you're going to get 1 over 3 into 4 times 1 square is 4 minus 1. And so 1 over 3 times 4 minus 1, that is going to be 3 over 3. And 3 over 3 is 1. So good there. So again, so therefore we can conclude, therefore P1 is true. So P1 is true. Now that P1 is true, we need to show that we need to assume Pn is true. And so when n equal k now, that's step 2, when n is equal to k, so let n equal k. So now that we let n equal k, all right, now that we let n equal k, we're just saying that the statement is going to become the sum from r equal 1 to k, sum from r equal 1 to k of 2r minus 1 square. And this is equal to n over k over 3 into 4 k squared minus 1. And we're going to assume that n equal k is true. All right, that's with n equal k. This stage you assume. So you're going to assume n equal to k is true. Assume that this step is true. So since we assume that it is true, it is true. We're just assuming. Now step 3. Now we need to show that n equal k plus 1 is true if n equal k is true. All right, so let n equal k plus 1 now. So when you let n is equal to k plus 1, this is what we are going to get. When n is equal to k plus 1, we're pretty much asking to find the sum from r equal 1 to k plus 1. The sum from r equal 1 to k plus 1 of 2r minus 1 all square, and the sum from r equal 1 to k plus 1 is equal to the sum from 1 to k, and the sum from 1 to k is this. The sum from 1 to k, which is k over 3 times 4k squared minus 1 plus the k plus 1 term. How do we get the k plus 1 term? We'll go in here and replace r with k plus 1. So that's going to become 2 times k plus 1, 2 times k plus 1, minus 1, all square. Nice and easy, soft. And we need to simplify out this now. All right, now this is really 2k plus 1. All of this is really 2k plus 1. So let's write that. All of this is really k over 3. This is really k over 3 into 4k squared minus 1 plus this part is really 2k. This is really 2k plus 1 all square. That's what we have, 2k plus 1 all square. All right. Now look what I'm going to do. Since I have a k over 3 right here, right, which looks, I want to have a 3 over 3 right here. So let me put it in a different color. You might say, so sir, why are you putting a 3 over 3 right there? Well, I'm putting a 3 over 3 right here, so it looks easier for me to factor out 1 over 3. That's the first thing I'm going to do. Let's do that around here. I'm going to factor out 1 out of 3. So what we're finally getting now is the sum from r equal 1 to k plus 1 of 2r minus 1 all square is going to be equal to, we're going to factor out 1 out of 3. We're going to factor out 1 out of 3, and we're going to be left back with, factoring out 1 out of 3, we're going to have k times 4k squared minus 1. We're going to have k times 4k squared, k times 4k squared minus 1. All right, and that is plus, when I factor out 1 over 3, I'm left back with 3 times 2k plus 1 all square. That's what I have. Nice and easy. So what do I do next? I continue. So I have 1 over 3 into, all you're going to do now is expand inside this bracket. K times 4k squared is 4k cubed. Then k times minus 1 is minus k, plus 3 times, now I need to expand what is 2k plus 1 all square. 2k plus 1 all square is first term square, so 2k squared is going to be 4k squared, plus twice the product of the two, which is plus 4k, plus second term square, which is plus 1. Cool. So that's what we get. So now we can do one more, expanding in the bracket to get, this is going to be equal to 1 over 3 into, it's 1 over 3 into 4k cubed. So we have 4k cubed minus k plus, no, 3 times 4k squared, that's going to be 12k squared. So we're getting 12k squared plus 12k plus 3. 12k squared plus 12k plus 3. Nice and easy. Now the only thing that we're going to do now is put this together in one pretty frame. We're going to put it together nice and pretty, and we're going to write it as 1 over 3. We're going to write it as 1 over 3 times 4k cubed. Then group up our k squared terms together. Grouping our k squared terms together, it looks like it's just the plus 12k squared. Then we're going to group our k terms together. Grouping our k terms together, notice we have a minus k and a plus 12k, so that's 11k. So we get plus 11k. And then what do we have left? We have just our constant, which is plus 3. All right, nice. So we have 4k cubed plus 12k squared plus 11k plus 3. All right. Now remember, what are we trying to get? What's the goal? The goal is to show that the sum from 1 to k plus 1 should be k plus 1 over 3 times 4 times k plus 1 all square minus 1. All right, we need to get this to be k plus 1 over 3 times 4 into k plus 1 all square minus 1. So that means we need to factor out k plus 1 out of this. The only way we can factor out k plus 1 out of this is doing polynomial division. Yes, I know it is tedious, but we're going to have to do it. So we're going to do that to the side in red. We're going to do a polynomial division. We're going to factor out k plus 1. We're going to factor out k plus 1. Factoring out k plus 1 out of 4k cubed plus 12k squared plus 11k plus 3. K into 4k cubed leave 4k squared. 4k squared times k is 4k cubed. 4k squared times 1 is just 4k squared. Then we're going to subtract these two statements from each other. Subtracting them. When we subtract, always put a bracket before you do your subtraction. You subtract them, you're going to get 12k squared minus 4k squared is 8k squared. Plus the 4k cubes cancel, so you have 8k squared plus 11k. And then k into 8k squared, that's just going to be plus 8k. And then you're going to go 8k times k plus 1, that's going to be 8k times k is 8k squared. That's 8k squared plus 8k times 1 is 8k. And then we're going to do some subtracting. When we subtract them now, we have 11k minus 8k is 3k. So we have 3k plus 3. Good. So we have 3k plus 3. Then we have k into 3k. That just leaves k into 3k. That just leaves plus 3. And then k times 3 is 3k. That's 3k plus 3. When you do the subtraction, clearly you're going to get 0. We don't even need to work it out. Clearly, we're going to get 0. All right, don't even need to work that out. We know that that is 0. No issues with that. All right, we know that's 0. So what does that tell us? That tells us then that we can rewrite this now as 1 over 3. Let me separate these pages. Let me separate this. That's just a rough work. You don't really need this in part of your solution. It's just rough work. All right, this is not necessarily a part of the solution. This is rough work. So this becomes 1 over 3 times, it becomes k plus 1 times, becomes k plus 1 times 4k squared plus 8k plus 3. Now when you get to this stage, now you can actually factor out the k plus 1. Now you're going to factor out the k plus 1 to say this is now factor out the k plus 1 it becomes k plus 1 over 3 times, and you're left back with what's inside the bracket, which is your 4k squared plus 8k plus 3. But remember, this is not how we want it. We don't want to leave it as 4k squared plus 8k plus 3. What are we trying to generate? We're trying to generate, this is what we're trying to generate. We're trying to generate 4 times k plus 1 all square. 4 times k plus 1 all square minus 1. So now I'm going to do some rough work again on the side. I'm going to show you this. What is k plus 1 all square? So this is some more rough work. K plus 1 all square, you're just showing them this. K plus 1 all square, doing some rough work. That is k square plus 2k plus 1. Alright, this is rough work again. Now, if you were to multiply this by 4, let's say if you multiply this by 4, it would become 4k squared plus 8k plus 4. And so if you were to then subtract 1 from it, then this would just become plus 3. So look. What are we then saying? See there? 4k plus 1 all square minus 1 is equal to 4k squared plus 8k plus 3. So we can replace all of this with that. So we can say all of this is actually just equal to k plus 1 over 3 times, we can write it now that all of that is 4 times k plus 1 all square minus 1. 4 times k plus 1 all square minus 1. So therefore, you can conclude now, therefore, pk plus 1 is true. Because we call the statement pn, so therefore, pk plus 1 is true. Now, generally, when you finish, you don't just done this. So always write a conclusion. Always write a conclusion. Always write a conclusion that hence, by mathematical induction, hence by can't bother write out that long word. Hence by PMI, the statement above is true for all natural numbers. That's your conclusion. This is step 4. Always write your conclusion. Always write your conclusion. Always. All right, that's the conclusion. Hence, by PMI, the statement above is true for all natural numbers. Question 1, soft. All right, question 2 now. Question 2 gives us a function f of x